All right, welcome to Module 1, the how and why of blockchain. So before we get started, please do take note of your thoughts. So take a moment, pause, get something to write on, whatever it might be, pen and paper or a text pad or something like this, and write down what questions come up for you as we're going through this. What terms don't you recognize, and what content is confusing or potentially missing? This will be the foundation for this week's discussion, so it's important that you have these on hand. It will make your job a little easier later on. So pause here and we'll come back as soon as you're ready. All right, so before there was blockchain, there were really many enabling technologies and systems that collectively come together to power blockchains. And that's really what we want to start with, is a foundation of understanding the pieces that came together that let this thing work. So very simplistically starting, what is a network, right? Well, really it's a group of anything that share links to each other. And in the context of this course and generally in the world, we talk about computer networks. We're connecting any set of electronics, wired or potentially wirelessly. And by electronics, I mean just about anything you can think of. It could be your smartphone, it could be your laptop, but it could also be the temperature sensor on the wall. Really, almost everything nowadays seems to have a connection to the internet, right? So the terminology that's typical when you're talking about this is a node is one unit, so one actor or individual who happens to be connecting. And the link is something that connects two particular peers on this network. So then when we're talking about what kind of peers there are, generally speaking, in today's internet, we have a whole bunch of servers that generally are a node that has many connections that are linked to it and can communicate between all these. Or we also have clients, which is a node that typically links with one of these servers, and that server will facilitate connections with any of the other nodes who are on the network, as opposed to, as you see in this little plot, all these individual actors connecting to each other directly. In the internet today, that typically doesn't happen, as we'll see. So what is the internet, right? Well, we use the words synonymously, but the internet really is something different. It's a massive network of networks. I really mean massive. And by network of networks, it is hierarchical in the sense that, as you can see in these diagrams, it kind of looks like a living map. And as an example, in your home network, you might have a handful of devices, maybe dozens of devices, that all connect through a router in your home out to your internet service provider, your ISP, that eventually connects out to some other networks. And then many layers down can connect to finally some machine out on who knows how many layers deep of these networks that you can communicate with someone else. So it really is a massive web, right? It connects millions of devices and sets more than just the device connections. The standards and protocols for that communication are defined. So you might have seen things in your web browser like HTTP and www. These terms really are defining how we communicate across this network more than just how do we make these links. So this is a bit of an outdated picture, but it does really give you a sense of the trends. In the first world, we have very high penetration of internet connectivity and access to everyone on the planet. But surprising, there's still plenty of people out there who don't have this. Something to keep in mind as we progress through this course is that it is not a guarantee. And most definitely as you move to the outskirts, the third world countries, this is definitely still a far cry from the norm for everyone to be having access to this large internet. So really, when you're on this internet, though, you can connect to almost any device, right? They all seem to be connected. And information can spread almost instantly across this, So we can have Zoom conferences with people in China and not even tell that there's a lag on the line, which is pretty amazing, right? And often, though, we connect to these services, whatever they might be on the internet, through secure and trusted central servers. So here's an outlook. Again, it's a bit outdated, but looking at basically the sessions that are queried, so how people are accessing the internet. And I know if you're anything like me, the big names, the icons you see here, are where we spend most of our time on this internet. So as opposed to connecting to these millions and millions of other devices, typically we're connecting to one or two central services like Google or YouTube or Facebook or Twitter, whatever it might be, right? And they're all central providers. So then if we circle back thinking about this, typically when we're connecting to one of these central servers, or really anywhere, we're interested in data, and how data is stored on a computer system is typically in a database, right? It's just a data storage system. Generally, this is accessible by many users to read data from or submit data to, and typically resides on some central server. So that's not always the case, and we'll dive into a little bit more in this, what other architectures are out there. But really, it's generally just a set of related fields. So here you can get an example. It's basically just an Excel spreadsheet that's abstracted in such a way that it's easier or potentially more optimal for computers to read. Why do we care about this? Well, things like your username could be there. Things like information about your account with a particular service can all live in these, right? And fundamentally, all of the social information that we might be interested in seeing is stored somewhere. And so one of these databases holds it. And typically, this is one of the more hype-driven words that we see in computer systems nowadays is the cloud, right? So what exactly is the cloud? And I think it really is a good euphemism for just somebody else's computer, right? You can use someone else's machine to run applications and store data out there on the world. So typically, cloud does a little bit of everything for you, out to the point that you don't even really need to have a machine except to be able to display whatever kind of information exists out on somebody else's computer here for you. So generally, this is accessible by many users, though. So it's typically not just you that is using a particular machine, can be, but it's generally shared on a network, and specifically the servers will provide this central service for you. And will perform operations for clients, right, as long as you get the right kind of permissions on this network. So we can dive more into the technicals, but authentication and validation on these kind of services is really important. So though we've talked a lot about it, there's central architecture seems to be the norm of where we are at today. But there are hints even today, and you might recognize some of these various logos here and icons of something different, a distributed network, right? So the internet can be central servers with a whole bunch of clients that rely solely on it, or potentially they can connect to each other directly and with no need for central servers. So this is effectively what it's referring to, is replacing the reliance on these central services and providers so that people can directly peer to each other to connect in whatever you might want to do. So there's a lot of pros and cons to think about when you're going for one of these systems, but generally this provides really good redundancy if this data needs to be out there on the network. Really good reliability in the sense it's not one service goes down, many different people can provide this service for you. So if one guy's down, you can go to somebody else. Security, there's pros and cons. We'll get more into it later. Scalability, though, generally speaking, if more people are running this and it's more redundancy, it can scale. And in terms of how many people want to access this network, can be much better. Operational overhead, it's a pro and a con in the sense that it's more distributed, it's more spread out amongst people, but it also is very much more hard to administrate. Right? If you have a single admin who gets to control the entire service as a provider, then you don't have to worry too much about this stuff. But it's really hard to coordinate amongst different actors with different potential things that they'd like to be administrating, different things they'd like to imply the network should do. So enter blockchains, right? What is a blockchain? Well, a blockchain is really, as we mentioned before, it's just a database. In particular, it's a linked list database where each new set of data is added, called a block, right, that directly references the previous one in this list. So what we have then is effectively a chain of blocks, blockchain, right? When we write one of these blocks of data, right, we know because it's referencing this last one in an immutable way, as we'll find out what that means shortly, we know that we can't change any of the history of this network data storage, this blockchain, without changing all of the following blocks that come after that in the history of this database. But really then, like, blockchain it's just a data structure. Like, why is there so much hype? Why are you in this course if it's just a fancy database, right? Well, it's more than that, right? We have a protocol that validates that no data has been changed or corrupted, as we're mentioning, that ensures it, in fact, and it's distributed across a network of peer nodes that must come to consensus on this data. So the thing that's really key here is that there is no single central authority. we have peer nodes that operate on a protocol that we all agree on, and we can cross-check that everyone's running the same protocol that then validate this data. It's not someone's job, it's the math's job to make sure that this is all working correctly, right? And then on top of this, we add game theoretic incentives to ensure that fair behavior is happening on these networks. So here, it's more than just we think that the math is going to be correct. We think the math is going to be correct, and we're going to make sure that human behavior is driven to drive these systems in the correct way and not try and cheat. And if they're found to be cheating, they're going to get hurt, basically, on this network in some way. Of course, there are some caveats from moving through all this. Private networks can be a little bit different when we're talking about blockchains. Typically in this course, the thing that I will be most excited about and the thing that I'm generally referencing is open public networks that operate blockchains. So we'll just keep that in the back of your mind. But then really summing it all up, what is blockchain? Blockchain is a distributed ledger that is immutable, meaning that no one can change this, right? Once it's there, it's there. There's no single point of failure, meaning that any attacks on this network, trying to censor data, trying to stop you from accessing this network, there is no one point that you can do this at. It's all across the globe. It's not controlled or operated by a single entity, so meaning there really is no ultimate authority in any sense of the term that controls or operates this network in any way. It's absolutely transparent. There's definitely some caveats to this, but typically speaking, blockchains are readable by anyone so that you can plainly see all of the information that's happening and landing on this network. There's no obfuscation, things like encryption and things that happen. And it's permissionless. So meaning that anyone can access this network and can interact with it without getting some authority by someone somewhere. Right? And of course, again, on private networks, a lot of these can be tweaked. And depending on the flavor of public blockchains, this may be somewhat more or less true, depending on what you're saying. So then bringing it down back to the base level, what does a blockchain really look like? So we're thinking about the structure of one of these databases, right? Is effectively we have back in history block 0, the Genesis block, and every block subsequently will reference the previous hash. So we'll get into this in the discussions and the readings this week. In particular, you take all of this information and generate a fingerprint, which we call a hash of this data, and then lock that fingerprint of this block, meaning that we can know that the block hasn't been tampered with, and put that in the next block, so that all along the way, we can validate that those fingerprints all match up with the data that's stored within the full block, and thus we can't change. This data becomes immutable, right? So here's the real concept though. Once you confirm something on this ledger, it's absolutely final, right? It's an open database that we can trust without trusting anyone who's using it. And that's really the novel thing here, is that typical cybersecurity revolves around very tight things like firewalls and access control lists and administration, right? Here, we don't have any of that. But we know for sure that this database, even though people want to change it, as we'll find out, cryptocurrencies are on here, right? So you might want to steal money or duplicate money, but you can't. So we trust that this system works without trusting anyone who's using it. It's pretty cool. So the last thing I want to leave with you is if you want to see what a blockchain looks like more than this little graphic that I was just showing you about how blockchains work, this live interactive explorer of the Ethereum blockchain in particular, that we'll get into a little bit more later on, is really cool. So ether.live, I think there should be a link in the description as well as these slides. You'll see you can hyperlink to this guy and explore, just see what's there. Clicking on these different elements will take you around to some different block explorers so you can see some of the information that's there. And it gives you a good sense of exploring what does all this stuff mean here. So don't be overwhelmed, take a peek. And with that, that's it. So some of the enabling technologies we've gone over here. And in the videos and readings, we're really going to jump more into the applied cryptography. So this is some of the stuff that we didn't talk on too much here, but how blockchains validate this stuff, those fingerprints, those hashes, as well as authenticating users on this network, right? It's permissionless, so anybody can set up an account. How do you go about doing that? How do you prove that you are the owner of said account once it's there? So applied cryptography is the foundation for that. You'll find out more there. Next module, we're going to be taking a deeper look at blockchain technology and really, as we alluded to here, cryptocurrencies, and talk about why blockchains really, they come hand in hand, why they're so good at doing this thing. And with that, we'll see you next time.